Hey class, today is 30-2 and we're going to be converting between radians and degrees and finding the area of a sector. And so that's going to be today's objective. We're going to convert radians to degrees and degrees to radians and then find the area of the sector of circular area. Now this is what we know about radians and degrees. We know that they both measure rotation, and from this example that I have shown here, we know that this distance, this rotation here is pi, and this rotation here is 180 degrees. Well, they're exactly the same. So because they both have the same rotation, I can make the statement that pi equals 180 degrees. Now, whenever we're converting between units, we're always multiplying by a factor of 1. So if I take this statement, pi equals 180 degrees, and I divide both sides by 180 degrees, you're going to get pi over 180 degrees equals 1. Or, if I have pi equals 180 degrees, and if I divide both sides by pi, I get 1 equals 180 degrees over pi. And so we have to multiply by one of these factors of 1s to be able to convert it. Now another thing to kind of realize, let's say if I had x degrees and I wanted those x degrees to cancel out, well, units cancel out just like factors do. So if I have x degrees and I want to convert that into radians, well, I'm going to multiply by pi radians over 180 degrees. Though degrees will cancel out as a unit, and then you just simplify from there. And so because of that concept, we have these two ratios that we can use. Pi radians over 180 degrees and 180 degrees over pi radians. So this first one, it says convert from 135 degrees to radians. So I take that 135 degrees, I want the unit degrees to cancel out, so I'm going to multiply by pi radians over 180 degrees. Now the degrees will cancel out. So now I need to kind of factor this and reduce. So what's something in common? 45. So 45 times 3. And then I have pi over, this would be 45 times 4. And so the 45s cancel out, and so I'm going to get 3 pi over 4 as my result. For this next one, if I want to convert these radians to degrees, so I'm going to get pi thirds, and converting to degrees, that means I want the radians as a unit to cancel out. So it's going to be 180 degrees over pi radians. The pi's cancel out, the radians as a unit cancels out, and so I have 180 degrees over 3, which is just going to be 60 degrees. Converting 330 degrees to radians, so if I have that 330 degrees, that means I need to multiply by pi over 180 degrees, so that the degrees as a unit cancels out. And then how does this all simplify? Looks like 30 degrees. That should work. And so then I get 11 pi over 6. And that's going to be my answer. Now if you want to divide top and bottom by 2 and then by 3, etc. until you find what reduces, you can do that as well. If I have 5 pi fourths, want to convert that to degrees, so it's going to be 180 degrees over my pi radians. The pi radians will cancel out as a unit. And then 4 and 180 degrees, that turns into 45. So 5 times 45 gives me 225 degrees. And so that's how we convert between radians and degrees. Now trying to find the area of a sector, we're going to use the equation A equals pi r squared. And so we're going to kind of use this concept to kind of help us. Now the issue here though is when we're trying to find the area of a sector, we only want a portion of this. Meaning, like, if I imagine this entire circle, the area of the circle, that's going to be the area. Well, the area of a sector is saying, well, I only want this much of it. And so we only want to find this much of the sector. So I need to use the concept of circumference to kind of help us with that. I know that 2 pi is going to be the entire rotation of everything, and that shows it's visually here. You know, it shows the entire rotation of that circle. Well, if I want to find what if I say I only have this much rotation though, what I'm going to do is I'm going to create a ratio of this entire rotation to that rotation that I have. So I'm going to say whatever the rotation is over 2 pi. And I'm going to have to take this ratio and I'm going to have to multiply it by whatever I get from my area. So let's look at this one here. I know that my area equals pi r squared. And so if I know that my circumference is 2 pi, it says, well, I only want a rotation of pi thirds. So pi thirds over 2 pi, which is the same as pi thirds divided by 2 pi. Now I got to flip that, so I get pi thirds times 1 over 2 pi. Well, those are going to cancel out, and I'm going to get 1 over 6. So I'm going to get 1 over 6 times pi times radius squared. And so that's going to give me 4 over 6 pi inches squared, or 2/3 pi inches squared. And you can enter that in your calculator, and you're going to get what your area is going to be. Now sometimes, if I have degrees, you can convert that into radians as well. And I could say, oh, the 210 degrees, convert that into radians, which if I did that, I'm going to get 7 pi 6. Now another way you can do it is like, well, why not I convert this into degrees if I'm just creating a ratio of it? And so I could say 210 degrees over 360 degrees times pi times r squared. Or I could say my area is going to be 7 pi 6 over 2 pi times pi r squared. And those would give you the exact same answer if you were to simplify that and enter that into your calculator. And same thing here, 270 degrees over 360 degrees times pi times r squared. And we can't forget we would have to have our unit feet squared as well. But if you'd simplify that into your calculator, you would get your answer as well. And so that's how we find the area of a sector. All it is just a certain percentage or a certain ratio of what the actual area is. And the way that we find what that ratio is, we just compared it to the circumference. To close today's lesson, what did we learn today? We learned how to convert from radians to degrees and degrees to radians. And we also looked into how to find the area of a sector. Now I want to hear from you. What is a way to visualize finding the area of a circle? And then how do I convert from radians to degrees? This does conclude our lesson. If you have any other questions, please leave them in the comments.